Okay, something else that you need to know when we're doing the polar coordinates is the radian measure of angles. Now, you already know about the degree measure of angles. So if we've got a circle here, and this particular circle that we've got has a radius of 1, then it will go through all of those points on the graph like so. Alright, and so this circle here has a radius of 1. So in degrees, along the x-axis 0 degrees, the y-axis up there that's 90, oops, not 50, 90 degrees, 180 degrees for halfway around the circle, 270 for 3/4 of the way, and then when you get the whole way around, 360 degrees. Alright, so we're used to that. Now, the radian measure of comes from looking at the circumference of the circle is 2 pi r. Now, in this particular case, when we've got a radius of 1, the circumference is 2 pi times 1, which is 2 pi. So that distance around that blue line from the x-axis all the way around any clockwise direction back to that x-axis would be a distance of 2 pi on that blue line. So the radian measure actually uses that, and so 0 radians is along the x-axis, and you go all the way around, you've got a distance of 2 pi, so that's 2 pi radians. Of course, if you go halfway around, you've gone pi radians. If you've got a quarter of the way around, you've gone pi on 2 radians, and 3/4 of the way around, 3 pi on 2 radians. That's what we've got. Alright, so it's another measure of an angle. No better, no worse than degrees, just different. But what you've got to remember is that 180 degrees is equal to pi radians. Right, and there's a whole bunch of things that you will eventually remember. 60 degrees is pi on 3 radians. 30 degrees is pi on 6 radians. Okay, now the little c up there that I've been putting represents radians. Often that's not put in. Alright, so when you're doing your polar equations, you can use either degrees or you can use radians, whatever the question specifies. Okay, so that's it. That's the radian measure of angles. You get to use that more and more as time goes on.